Hello and greetings from Brunei Darussalam. This is a joint presentation from Ms. Sarisa Vina Rinawati Sharani Muhammad Leong of the Paduka Sri Begawan Sultan Science College at the Ministry of Education, as well as Associate Professor Dr. Quintus Pereira and Dr. Masita Sharil of the Sultan Hassan Al Bolkiah Institute of Education at the University of Brunei Darussalam. This study focuses on the identification of physics students' misconceptions on manometer reading and determining gas pressure in 2 secondary schools in Brunei Darussalam. Following this, we explored on how the students understand the concept of pressure and highlight the various points of their misconceptions. Physics is commonly regarded as a difficult subject. Physics is also known to be an abstract subject whereby most of its concepts are intangible and hard to imagine. According to Ornack, Robinson, and Hogan in 2008, they found that physics is difficult to students as it requires them to extend their understanding to various representations beyond experiments, formulas, and calculations all at once. One example is the concept of pressure. The lack of understanding can easily affect students' learning in related topics, as it can be found similarly alongside other subjects, such as chemistry, and involving the physical changes in the rate of change of chemical reactions, or even biology or medicine concerning blood pressure. Moreover, in learning and understanding of the concept, it is crucial that it is thoroughly understood, or it may lead to misconception. The purpose of this study is to identify the gaps of students' understanding of pressure, generally, and manometer reading specifically, and if there exists any misconceptions. Referring to the diagram, a manometer is an instrument that uses a U-tube containing a liquid, either mercury or water, to measure gas pressure. In highlighting students' understanding of pressure, it enables researchers to follow back as to how much the students grasp the concept. Tyler's study in 1998 found that students in various age groups failed to recognize air pressure while completing science activities focused on air pressure. As outlined by Padir and Pradhan, the tendency to replace the complicated concept of pressure with similar ones is common. Students often mistake force for pressure, and they picture pressure as forceful and one-dimensional, as opposed to a state that is ambient and multidirectional. However, the confusions between force and pressure were not seen in our research study. What was discovered when investigating the possible causes for the struggle on manometer reading was the non-obvious causes and effects of pressure. This was further elaborated by a number of studies whereby, due to a non-obvious nature of pressure, there is a tendency to substitute active causal agents for passive ones. Hence, it was discovered in the research conducted that students perceive pressure as non-existent or vacuum, as it cannot be seen. In learning science, many students are still holding the same misconceptions that they had prior to teaching, and regardless of this knowledge and problem solving, they often fail to comprehend basic concepts. There are many researches done with regards to misconception in science, and most of them pointed out that what teachers teach and what students actually learn varies remarkably. Misconception or alternate conception is part of the student's private knowledge that is, strictly speaking, not completely consensual by scientific standards, though it may make sense to the student himself. The ultimate purpose of this research is to achieve conceptual change that not only confronts problems concerning teaching strategies, but it also tackles misconceptions the students possess. In conceptual change, an existing conception is fundamentally changed or even replaced, and becomes the conceptual framework that students use to solve problems, explain phenomena, and function in their world. According to Hewson, when taking into account conceptual change, it is helpful to recognize the word change. change as described by Houston and Houston is either entirely or partly altered or exchanged, and this is consistent with what this strategy is trying to achieve, and it suits the purpose of this study, that is promoting learning that changes an existing misconception or incorrect ideas of pressure concepts. Sil and Stepney in 2012 claimed although students' conceptions were not entirely in line with scientific explanation, however, there were major shifts in understandings. This focused on the shift and restructuring of existing knowledge and beliefs of which that distinguishes change from other learning. For our study, we introduced a new concept so that students are enabled to reconcile the new concept with current knowledge and experience. Then experiences and information were provided that helped students make sense of the new conception. The sample was taken from 2 government secondary schools in Brunei Darussalam, and it involved 11 Year 9 students with the age varied between 12 and 14 years old. The quantitative data from the larger study was collected by using suitable pre, post, delayed post, and confirmatory test instruments, which consisted of questions intended at diagnosing the misconceptions as well as conceptual understanding of the students involved. The qualitative data were elicited from the interviews and video recordings. For the interviews, a few students were selected, not more than 3, from each class, and the selection was based on the incorrect answers and justifications they gave during the pre and post tests. The interviews were done to collect in-depth data on their views regarding specific incorrect responses given. The results reported here would only be from the analysis of the student interviews. As mentioned earlier, a total of 11 interviews were conducted to collect in-depth data on the students' understandings and difficulties when doing the post-test questions. And the focus of the interview was directed on items 1, 2, and 3 of the post-test questions in this figure. From the interviews conducted with the 11 Year 9 students, 2 main misconceptions on the manometer readings were found. The first misconception was on the existence of air pressure. Students failed to recognize its presence, as the effects of air pressure are often not obvious and undetectable. According to Karagioglu and Silos, students are oblivious to the presence of air pressure, as the effects of air pressures are often not obvious and undetectable. Additionally, 2 students on 2 separate interview occasions had referred to air pressure as vacuum. Students 1 and 2 gave the following responses to items 1 and 3 of the post-test questions during the interview. The second misconception was mistakenly taking the high liquid level of a manometer column as high pressure acting on that side and vice versa. This misconception is caused by again failing to comprehend that air and also gas pressure can cause liquid levels to change. Moreover, in identifying the height difference, there were 5 out of 11 students interviewed who failed to grasp the true meaning of height difference of a manometer. This can be seen when the 3 manometer questions set for the test were labeled differently. Even from simple manipulation of the diagrams, these had caused a lot of confusions for the students. As was seen from the results obtained, students did have misconceptions with regards to manometer reading, which were inconsistent with scientific views. The interviews conducted revealed that majority of the students had difficulties in fully understanding the true meaning of height difference of a manometer, and simple labeling manipulation of manometer readings had resulted in many incorrect replies made by the students. As was highlighted in the study by Pader and Pradhan, what students could not see was a solid basis to assume that nothing was there. In other words, it can be concluded that the expression "looks can be deceiving" is appropriate to describe the misconceptions some students may possess. In addition, Identifying these misconceptions will indeed assist physics secondary school teachers to confront the issues relating to the difficulty concerning the pressure concept. A foolproof lesson development must be propagated in order to fully address that the topic is aligned to the scheme of work in order to prevent from the problem be repeated. Similar feature studies can also be done in other science subjects with regards to pressure concepts and to observe if the misconceptions also exist. If so, then, further investigations should be done to tackle the root of the cause, as the underlying reason could be the justification why related misconceptions occur in all the sciences. These are the references used for this presentation. Thank you for listening. If you have any inquiries or comments in relation to this study, please email them to us.